You've been asked to plan a practical to determine a rate equation. The reaction you're looking at is the reaction between iodine and propanone. Now, one of the sources you've been given is an extract from an prac book, which is a great source to start with, but this is not the only source you should be using. The extract from prac gives us a really good aim. It tells us the purpose of this experiment is to obtain the rate equation for the reaction between iodine and propanone by determining the order of reaction with respect to each reactant. That means we're going to have to do 3 distinct experiments where we vary the concentration of the iodine, the propanone and of the acid to see what effect that has on rate. Now, the way we're going to measure rate with this one is by using a colorimeter. Now, the only thing that's coloured in this particular mixture is going to be the iodine. Now, iodine is a sort of browny orange colour. As the reaction goes ahead, we get iodide being made, which is colourless. So we're going to get a loss of colour. Now, if we can measure that loss of colour, we can directly relate that to concentration. If we can measure the change in concentration, then we'll be able to get a rate. The introduction tells us nicely how this breaks down. It tells us how we're going to be able to choose a filter for the colorimeter. This is to make sure we get the maximum absorbance and can get a reading that we can use. It takes us through how we're going to calibrate the colorimeter. So we can create a calibration curve and convert our absorbance values into concentrations, which is going to be essential if we're going to draw a rate curve, and be able to work out a rate of reaction. It also then tells you how you're going to vary the different concentrations while keeping 2 constant. This next page tells you how to set up your calibration curve. It goes into more detail than perhaps you need to in your method, but your method should be one that you could give another student and they could follow easily. So it tells you how to choose a filter. Now, it'd be fine to say you've done some research and that you know a filter in the blue-green range is going to be suitable because that's opposite on the colour wheel, so that's going to give you maximum absorbance. You don't need to explain all of this section, but you would then need to say how to use it. So you need to say that you're going to put the suitable filter into the colorimeter, zero it using water, and then you're going to set up a calibration curve. Now, it's fine then just to skip to a table like this, but have a think about it. Look at the volumes they're using. That's 10 centimetres cubed. Think of the little cuvettes we have in the lab. Do they take 10 centimetres cubed? Might be you need to get one out and have a look. But make sure your information for your calibration curve is using volumes that will actually fit into those cuvettes. So you are then going to get a graph. And it's going to be absorbance against concentration. And that means that any future values you get when you're doing the experiment, you will be able to convert absorptions back into concentrations, which is what you're going to need to be able to do to work out change in concentration, therefore the rate. So you've set up your calibration curve. It is now time to start the actual experiment. Now you're going to do 3 different experiments. One in which you vary the concentration of propanone, and then you keep the concentrations of iodine and hydrochloric acid the same. They are variables which you are keeping the same. Then you're going to change iodine, keep the other 2 the same. Then you're going to change acid and keep the other 2 the same. Now, if you take a reading of absorbance every 10, every 20 seconds, then what you're going to find is you end up with enough data to plot yourself a curve. Now, you can convert those absorbances into concentrations, and you've got a concentration against time graph. That is going to allow you to work out your order of reaction. Your rate is going to be your initial rate is going to be the initial gradient. So for each one, you're going to work out an initial gradient which is equal to the initial rate. You can also get an initial concentration. So by doing a variety of these experiments, for each one you are going to get a table that says experiment 1, 2, 3. You're going to have an initial concentration, for each of the propanone, the iodine and the acid, and you're going to get a rate. You should recognise that sort of table. This is where you look to see what the change is going from one to the other and see its effect on the rate. By doing that, you can work out the order. So that's where you're trying to get to with this experiment. Now be careful again with this, because these are volumes. If you have a look at all of those added together, are they going to fit into a cuvette? If they're not, you need to reduce them. There'd be no problem halving all of those. This is a good guideline to use. Okay, so your plan. You should have an introduction, stroke aim. What are you doing and why are you doing it? 2. You want to show how to set up a calibration curve. And why are you setting it up? It's so you can then convert those absorbances into concentrations. 3. How are you going to carry out the experiment? I need to be able to give this plan to somebody else and they need to be able to pick it up and easily be able to follow it. Not to say just change the concentration. They need to know exactly how they're changing it. So if 2 different people did the experiment, they should get the same results. You want to highlight any variables and state how you're going to control them. On the first attempt at this, a couple of you mentioned temperature. Now, it might be really hard to control the temperature, but you can certainly measure it. And if there was a dramatic change in temperature, that might help you explain any problems with the results later on. Make sure you mention all volumes that you're going to use and concentrations. If you want to put them in a table so they're easier to follow, that's absolutely fine. You can say make up a variety, use the table below as guidance. Make sure you're thinking about how much you can fit into a cuvette as well. As I said previously, there's no problem in getting a cuvette out and checking to see how much fits in it. You want a blank results table. And then, whether it's you or somebody else carrying it out, they know the sort of results they're going to be looking for. You want a description of how the results are going to be processed. In this case, you're going to have to draw graphs initially to work out the rate. You're then going to have an initial concentration, an initial rate for each reaction. And you're going to use these to put a table together which would have the experiment, 1, 2, 3, 4, etc., the initial concentration of each of your 3 reactants and the rate for that. And then you're going to use that table in the usual way that you have to work out the order. Once you've got the order, you can suggest a rate equation. Now, if I was doing this experiment, I'd also want to know the hazards. Do any parts of it need to be done in a fume cupboard? Is it safe to handle the glassware? Is there anything I need to watch for? So when writing a risk assessment, you have to think about each hazard. Now, all of the chemicals you're using need to be risk assessed. So you'd put propanone, iodine, etc. So you've identified the hazard. What's the risk from it? Might be you need to use the HAZ cards to see whether they're toxic, whether there's a problem, whether they're safe to use below a certain concentration. Then look back, see what concentration you've suggested, see whether it's safe. And then any action. So is there anything you can do to minimise the risk? If there was a problem with it, what would you do? What actions would you take? So you're doing this for all of the chemicals. You're also going to do this for any glassware. If you're using anything that has a plug on it, that has the potential of an electric shock, so you need to say what you do to minimise it. You wouldn't handle a socket with wet hands, for instance. So think about each hazard, its risk, and what action you can take if something bad happens or to minimise and reduce that risk. Finally, you've used sources to write this. You've certainly used the ILPAC book, so that needs to be credited. We have a copy in the lab if you need to find out the information about it. Nothing should have been directly copied from it. Everything should have been adjusted slightly. Because the volumes are not suitable for the cuvettes, you probably reduce them. But you do need to credit the source. There may be other sources you've used for the risk assessment. You might have used the HAS cards, which are available if you ask for them. You might have used internet sources. Make sure all of these have been fully referenced at the end of your plan. Okay, now you've watched this, go back and have a look at your plan. Some of you might just be able to add a little bit of extra information. Quite a few of you are going to need to rewrite this. I will then check it again before I allow you to carry it out.